Hey everyone! In this video, we're going to be taking a look at reflections. So what I'd like to do is first take a look at the mathematical definition of what a reflection is, and then I'd like to show you how to do an example with a specific object in the coordinate plane. So to begin with, a reflection, basically what it is we're going to use a line as a mirror to flip an object. That line that we're going to flip over, we call that the line of reflection. And there are two cases we need to consider. So to start with that, I have two different lines here. And let's say that these are my lines of reflection. And I'm just going to say that it's called line M. The two possibilities are if I have a point or points not on line M, or if that point is actually on top of the line. So these are our two scenarios that we want to consider. So when the point is not on the line, we're going to use line M sort of like a mirror, and we're going to reflect point P onto the other side of this line. Now there are two conditions that are going to be met. Basically, line M is going to become the perpendicular bisector between my original point and its image. So perpendicular bisector, there's a couple pieces there. So the first thing is it's going to form a right angle. So from P, if I go straight down to line M, this forms a right angle, and I can know how long this is, and then I want to do the exact same thing on the other side of line M. So a segment with the exact same length and also perpendicular. So this also forms a right angle. It has the same length. And at the end of that segment, that's where our image is going to be. This is P prime. So that's the two pieces that make up a reflection. Line M is the perpendicular bisector. So the image is the same distance away from the line, just on the other side. And it's the segment between P and P prime is perpendicular to our line of reflection. In our second case, point P is on top of line M. Now, I can't draw a perpendicular bisector here, right? There's no way that I can fit a segment in there because the line goes right through my point. So instead, what happens is point P actually just flips on top of itself. So my image is actually right where we started. So P and P prime are right on top of each other. They don't move. Okay, so now that we have an idea of what a reflection is, to put this in an example, I have a triangle ABC with the vertices 1, 3, 5, 3, and 2, -1. And I want to do two different reflections with this. So I want to do one reflection in the x-axis and one reflection in the line x equals 4. That's the way that we normally phrase it. We say we're going to do a reflection in this specific line. What that just means is that line that we're given, that's our line of reflection. So let me start by graphing this triangle. So we have 1, 3 for point A, 5, 3, 1, 2, 3, 4, 5, and 3, and 2, -1. So this was A, B, and C. And I'll connect these together to form my triangle. Okay, so our first reflection, we are going to reflect over the x-axis. The x-axis is our horizontal one, so we're going to flip our triangle over this line. Now, thinking about our definition for a reflection, we know that the image is going to be the same distance away on the other side of the line, and the segment that connects our pre-image with our image has to be perpendicular to our line of reflection. Well, in this case, since our line of reflection is horizontal, I know that the segment connecting together my pre-image to my image is going to be vertical. So we can just count here. So for point A, I know that it has to be perpendicular, so I'm going to go straight down, so I'm going to go vertically. And then A prime has to be the same distance away on the other side of the line. So from A, it's 1, 2, 3 units to get to my line of reflection. And then I'm just going to repeat that on the other side. So 1, 2, 3 units. And here's going to be A prime. Now I can just do the same thing for my other points. B is also 1, 2, 3 units away. So then 1, 2, 3 units away on the other side gives me B prime. And now point C is actually on this side, but we're going to flip it back over to the other side. It is 1 unit away. So then we go 1 unit on the other side, and here's C prime. And again, I'll connect these together to form our new triangle. Okay, so here's our image after our first reflection. So as you can see, the points are the same distance away on the other side. The segments connecting together, the pre-image to the image, are perpendicular. And also we can notice that our new triangle, the triangle A prime, B prime, C prime, is congruent to what we started with. So this is a rigid transformation. Let's just go through that process one more time for our second reflection. So now I want to reflect this in the line x equals 4. So x equals 4, that is a vertical line going through the x value of 4. So 1, 2, 3, 4, that is the vertical line right here. And then we'll just do the same thing, the same idea. So if I start with point A, I'm going to flip this over our line of reflection. A is 1, 2, 3 units away. And now I'm going to go 1, 2, 3 units on the other side. And I'm actually going to call this one A double prime just to differentiate. For B, we're 1 unit on the right. So we'll flip that over to 1 unit away on the left. And that's B double prime. And lastly, for point C, moving horizontally, C is 1, 2 units away. So we go 2 units away on the other side, and here's our reflection. So there we have it. That's how you do a reflection. So again, the big idea, there are 2 pieces to a reflection. So we're given that line of reflection, and what that ends up being is the perpendicular bisector between the pre-image and the image. What that means is that the pre-image and the image are the same distance away from that line of reflection, and the segment that connects those 2 points together is going to be perpendicular to your line of reflection.